Are you ready to stop guessing and start understanding? Welcome to Restaurants Academy, the place where the toughest concepts in science and mathematics finally make sense. From calculus to chemistry, we break down complex problems into clear, step-by-step solutions. Hit subscribe and join us. Let's master the logic of universe together. Let's talk about pressure, specifically in solids. So pressure P tells us how concentrated a force is. So mathematically it's got to force divided by the area. And the C unit for pressure it is Newton per meter square or Pascal. So pressure we experience it in real life, like when you are using a knife. We used to use the very sharp edged side like this one. For example, when you are using a syringe, we use it to very sharp end. Just as the sharpness increases, we are decreasing the area, and as the area decreases, pressure will increase. You have to keep that in mind. So let's we try to show it by using this formula. P is equal to force divided by this area A. So as this area decreases, this pressure P will also increase. It will work vice versa. And as as this area increases, the pressure will decrease. Pressure P will decrease. You have to keep that in mind. Let's take an example and we say that we have a force of let's say 10 Newton that is acting on area number 1. Let's call this A number 1, which is equal to for example, let's say 2 which is equal to 2 meter square. This will produce a pressure P of to be equal to 10 Newton over this 2 meter square. This will produce a pressure P of 5 Newton per meter square. But let's we assume that the same force it is acting on area number 2, A number 2, which is equal to, for example, 1 meter square. Let's use a different color here. This will produce pressure P, which will be equal to force again over area. This will be equal to area number 2. This will be also equal to pressure number 2. As this area number 2 is smaller compared to area number 1, the pressure P number 2 here will be equal to the same force, which is equal to 10 Newton divided by 1 meter square. Let's we try to put the answer here. This P number 2 will be equal to 10 Pascal, which is evident as this area increases, the pressure automatically will decrease. So here we have a real example. Here they give us a chair, as you can see it here, with 4 legs, and they are telling us this chair raised, or it has a weight which is equal to force of 80 Newton, and each feet of the chair here we have an area of 10 centimeter square. So the total area that 4 feet of this chair has will be equal to it will be equal to 10 centimeter square as of 1 foot times 4, which will be equal to 40 centimeter square. So you have to keep in mind that always when you are finding force, pressure, area should be in meter square, not centimeter square or in other unit. So we take this 40 centimeter and we convert this into meter square. We divide by 10,000, which will gives us 0.004 meter square. Then our force here, pressure P, to be equal to force, which is equal to 80 Newton, divided by this is 0.004 meter. This way gives us 80 over 0.004, which really gives us a pressure of 2,000 Pascal, which also can be written equal to 20 kilopascal, knowing that this prefix kilo is equal to 10 to the power 3, all times 1,000. Keep that in mind. So then here they give us another box of mass M, which is equal to 75 kilogram, and they give us G, which is equal to 10 meter per second square. So weight here, or which will be equal to force, will be equal to mass times acceleration due to gravity, which will be equal to 75 kilogram times 10 meter per second square, which will be equal to 750 Newton. So pressure here, we are still missing the area. Area, as we can see here from the box we are having here, this is the very side of this box that is in contact with the surface. So area will be equal to length times width, which is equal to 6 meter times 5 meter, which will be equal to 30 meter square. So pressure here, pressure P, will be equal to force, which is the weight we calculated above, 750 Newton, divided by 30 meter square, which will be equal to 25 Pascal. So you have to keep in mind that always as this pressure increases, as the area increases, the pressure will decrease. That's all. Thank you.